Hi everyone, in this video we are going to talk about the Pythagoras theorem and we are going to see how to prove it. The Pythagoras theorem applies to right angle triangle. Suppose we have a triangle like this whose side lengths are A, B and C units. C is the length of the hypotenuse of course, and A and B are the two sides which are adjacent to the right angle. For such a triangle, the Pythagoras theorem says that the square of the hypotenuse would be equal to the sum of the squares of the other two sides, which means in this case, because hypotenuse is C units, so C squared would be equal to A squared plus B squared, or in other words we can say A squared plus B squared is equal to C squared. Now let's see how we can prove it. I'm going to draw a quick diagram here and then we'll do the proof. Let's suppose we have a square ABCD whose side length is A plus B units. I mean each side of that square is of the length A plus B units, and in that case what would be the area of the square? The area will be square of the side length, so in this case the area will be A plus B whole square, and that would be of course in the square units. And you can clearly see in the diagram how I have divided each side of the ABCD square, how I have divided each side of that square into two parts, right? One part is A and the other part is B. Let's assume that A is the larger one, B is the smaller part. After dividing each side into two parts, what I have done? I have joined those points, right? I have joined the point E with F, then F to G, then G to H and H to E. That is how I have joined those points, and those points actually divide each side of the original square into two parts which are A and B units, right? And now if we look at the two triangles here, let's suppose we have triangle EAF. So now let's talk about these two triangles, triangle EAF and the triangle FBG. Now if you look at these two triangles, we can notice a couple of things. First of all, what is this angle? The angle A right here, well that is a right angle because ABCD is a square. That means each of the angles should be right angles. So I'm just kind of indicating that with a red square kind of shape at the angle. So each of those angles are right angles. That means angle EAF is a right angle, and similarly angle FBG also a right angle. And then the side EA is equal to the side FB, and similarly the side AF is equal to the side BG. So here you can see we have two triangles where the corresponding sides are equal and the angle between the corresponding sides that is also equal. That means these two triangles are congruent triangles. For the side angle side property of congruence, we can say that these two triangles are congruent triangles. So I'm going to indicate it like this. We'll say these two triangles are congruent. Now because they are congruent, then their other side will also be equal. That means the side EF and FG, they will be equal. So can I indicate it like this? So EF and FG will be equal. And similarly, if you take the triangle FBG and the triangle GCH, you can prove that FG will be equal to GH. And similarly, you can prove that GH will be equal to EH. So essentially the inner quadrilateral which is inside the original square, that inner quadrilateral has all sides equal. We still don't know whether it is a square or a rhombus, but at least we know that all sides of that inner quadrilateral are equal length. Now let's do a little bit of angle analysis. Since we have proved that triangle EAF and triangle FBG, they are congruent, then we can say, well, then this angle will be equal to beta, the angle BFG, this angle will be equal to beta, and also the angle BGF, that will be equal to alpha. And then now let's take a look at this angle right here, which I'm going to highlight in a light green color right here, or maybe let me highlight in a green color right here. So suppose I'm talking about this angle right here, the green color angle, which is actually the angle EFG. Let's assume that this angle is X. Then what can we say? From the triangle EAF, we can say alpha plus beta is equal to 90 degree because the other angle is 90 degree, and we know that the sum of three interior angles of a triangle is equal to 180 degree, and because each of those triangles are right triangle, then obviously alpha plus beta will be the remaining 90 degree. So from this triangle we can say that alpha plus beta is equal to 90 degree. Now if you think about these three angles right here, so first let me write down the angle names. So now we are talking about these three angles, angle BFG plus angle EFG plus angle EFA. The sum of those three angles is actually forming a straight angle right there. It's all on that side AB. At the point F, it is like one straight angle there, and that will be 180 degree. Now what is angle BFG? Well, angle BFG is actually beta. So from here can we say that beta plus what is EFG? Well, angle EFG is actually X. That's what we are going to calculate, the value of X. And then plus what is angle EFA? Well, angle EFA is actually alpha. So this sum is equal to 180 degree. And from here, what is the value of X? Well, X plus alpha plus beta. So you can say X plus, then we can enclose alpha plus beta like this is equal to 180 degree. And from here, we know that alpha plus beta is equal to 90 degree. We have seen it right here. So you can say X plus 90 degree is equal to 180 degree. And from here, we can say, well, then X must be equal to 90 degree, which is 180 degree minus 90 degree. So that would be 90 degree. So here, the inner quadrilateral, which is EFGH, that quadrilateral has all equal sides, meaning all sides are of equal length, and also it has an angle which is 90 degree. X is actually 90 degree. So let me make a quick note in the diagram. So X is actually equal to 90 degree. That means the inner quadrilateral is nothing but a square. And if it is a square, can we assume that the side length of that square is like this? So I'm now going to say, okay, let's assume that each side of the inner quadrilateral, which is the inner square, we have already proved that it is a square, and let's assume that each side length of that inner square would be C units. So I'm just going to write C here, and then a C over there, and then a C over here, and then a C over here, lowercase c. Right? Now can we say like this, that the total area of the original square ABCD will be equal to area of the four little triangles plus area of the inner square? Think about it. From the diagram, it's very obvious that the area of the outside square, which is ABCD, that will be equal to the sum of the area of those four little triangles plus the area of the inner square. That sum will be same as the area of the outer square. Now from here, let's do a little calculation. So now, what is the area of the four triangles? Well, the area of each triangle would be half times A times B. So 4 of them. So I can say, well, half times A times B, that is the area of each of those triangles, and if we multiply that by 4, that would be the sum of the area of all those 4 congruent triangles. And then we are going to say plus, what is the area of the inner square? Well, the inner square area, which is EFGH, its area would be the square of its side. And what is the side length? Well, we have assumed that the side length is C, so you can say this is equal to C squared. Now what is the area of the original square ABCD? Well, its area would be A plus B whole square, which I have up there. So now can we write it like this, that area of the square ABCD, which is A plus B whole square. So now I'm going to say, well, then A plus B whole square, which is actually the area of the square ABCD, will be equal to half times A times B times 4 plus C squared. And then from here, can we say that A squared plus 2AB, 2 times A times B, A squared plus 2AB plus B squared, that is the left hand side, and that is equal to, here we have half times A times B times 4, so that would be 2 times AB, so 2 times A times B, that would be 2AB, and plus C squared. And you see, we have 2 times AB on both sides, positive 2 times AB, that will cancel each other. So from here, we can say, well, now we are left with A squared plus B squared is equal to C squared. And that's exactly what we wanted to prove. So let me write down the final result here. We have obtained that A squared plus B squared is equal to C squared. And if you now look at the diagram, let's look at the diagram here, original diagram, we'll see that if you look at one of those little triangles, let's say for example the triangle FBG, if you look at that triangle, you will notice that C is the hypotenuse of the triangle, of that right triangle, and A and B are the adjacent sides of the right angle. So now we can clearly see that we have been able to prove that the square of the hypotenuse of a right triangle is equal to the sum of the squares of the other two sides, which is A squared plus B squared is equal to C squared. I hope everything made sense. Thank you for watching. See you in the next video.